7.5 superposition of wave. So this subtopic we want to understand, we want to learn about standing wave. So before we proceed to standing wave, the most important thing is we must understand the principle of superposition, right? So the first part would be superposition of wave. This is the one. So when two wave 1 and wave 2 interact between each other, right? Interaction happen. So the resultant wave is based on y1 plus y2, total displacement of each individual wave. This is what we call as superposition, principle of superposition, which is the vector sum of individual displacement. That means that two wave, the vector sum total, both of them, is equals to the resultant wave. This is your principle of superposition. Now, once you understand the concept of superposition, right, principle of superposition, we use this to explain our interaction. The first one will be constructive interference. The second one will be destructive interference. So what is in constructive and destructive? If you look at this diagram, this is example of constructive and destructive interference. So any interaction between the two waves that result you applying principle of superposition, if your y value is higher, increase in displacement. So this one we call it as constructive interference. If your resultant applying principle of superposition, if the resultant wave is lower or reduced, right? So this one is what we call as destructive interference, right? I give you another example. There's two waves that I prepared here. Right, if there's one wave here interact with another wave, this is the two wave interact with each other. So this wave 1 and wave 2 total up together, so we will end up with, so our wave here would be, since that principal superposition means that the y here will be vector sum. So for example, if this is your A amplitude, this is also have the same amplitude, identical wave. So once you combine, you will get a higher amplitude. This is what we call as constructive interference. So when this one, the amplitude here will be equals to 2A. How do we get 2A? From principle of superposition. Principle of superposition state that y is equals to y1 plus y2. So in this case, the first one is amplitude, second one amplitude will be A, so you end up with 2A here. This is for constructive interference, right? So this is the resultant wave. Now, how about destructive interference? Constructive interference. How about destructive, fully destructive? Right? So fully destructive, I'm going to use the same wave. If one wave interact with another wave, right, so I'm going to paste another wave, but this time I'm going to correct slightly, right? I'm going to reduce this one. If this is the wave interact between each other, this is the wave. Right, if this wave plus this wave, interaction between both of these waves, so what do you get here? This is, you will get the resultant here. The resultant here, this one, you will end up with, the wave will be like this. Why? Because if this is your amplitude, this is your negative amplitude because it's downwards. So if your principal superposition is equals to y1 plus y2, so in this case A plus negative A, you will end up with 0, no amplitude. So this is what we call as destructive interference. Right, you end up getting this one. This is how we be able to apply principle of superposition to explain constructive interference and destructive interference. Now, so once you understand constructive and destructive interference, now we try to discuss how the formation of standing wave. I think most of you have seen standing wave formation from experiment 5, right? Where I think experiment 6, okay, where you see that the wave, right, through the string, you'll be able to see the standing wave. How standing wave is being formed. Now, let me explain this using diagram 2, right? So, for example, one wave moving one direction. So, we talk about this thing based on few scenario. The first scenario would be wave moving towards each other. Interaction between two waves. Right, this is the two wave. But I'm going to modify it slightly. So the wave will be something like this. This is the two wave interact with each other. So interaction of these two waves. So this is when the time is equals to 0, beginning of interaction of these two waves. Now once this interaction happen, right, so we will end up with, so resultant from these two interference, so we end up with destructive interference. Since that this is positive, this is negative, so we get one line here. This is your formation of wave, right? Now what happen if the wave now is moving, both of these wave is moving opposite direction. One is moving to the right, one is moving to the left, right? This is your from our perspective. So what happens if next, I'm going to copy this. After another quarter period, so another quarter period, as you can see here, right? So I'm going to draw a diagram here. So you will see that the wave now is moving quarter period. So I'm going to pull this one and move somewhere like this, right? And after quarter period, this wave also moves to the right, will move somewhere like this, right? Somewhere like this after a quarter period. So what happened to the interference now between the two wave? So this one two will interact with each other. So I will get equals to, so the superposition of wave here, you will end up with what we call that, this one will become a constructive interference. Both is amplitude at the same point. But because it's bottom here, so the resultant would be something like this. This is your superposition, right, between the two. So the amplitude here will be equals to 2a lah, but it's at the negative side. Because this is a, this is also a, right? I'm going to write down here, this is a, this is also a. So you get 2a here. Right, this is the product of interference. Now if another quarter period pass by, right, so what happened to the superposition now, right, between the two waves? So I'm going to copy this diagram, right? So again, I'm going to proceed to move this wave to another quarter period. So I'm going to move this one to the right, something like this. So and then I'm going to move this wave to the left and right to quarter period. So again, I'm going to move something like this. Right. So what do I get here? This 2 point, when it is experience interference at 2 point, we will end up with, if this is the line, right? So these two will end up, one is positive, one is negative. So from interference here, I will get again destructive interference. So my line here will be one line like this, destructive interference, right? This is the third quarter period. So the next one, the final one complete period, and then the wave will proceed to move. So I'm going to copy again this one, copy again, right? So what happens if the wave proceed to move to the left? So again, I'm going to move the wave now to the left, another quarter period. This one will move to the right, another quarter period. So I will get something like this. This is how I'm going to extend. Right, this one will be going here. So what happened to my interference now? So as you can see here, this one you will get another constructive interference. Right, but this time it will be started from right, the top here, from this point. So the line will be from here. So we get up with two amplitude. What do you get here? This is your constructive interference with the amplitude here. This is your A. This is your A. So we end up with 2A here. Right, this is the last quarter period. Right, and then of course if you proceed, you will end up with repeat the same thing. So what we have is once the superposition standing wave occur, the wave this we will see the resultant image of this, the first quarter period, and then this, and then this, and then this. So we will be able to see this four image, very short time interval in one period. So we will see this four image. So what happens if I combine this four image in one period, so the time move very fast. So I combine all these four image. The first one, I'm going to pull this one here. The second one, I'm going to pull this one here. The next one, I'm going to pull this one here. So if this four, I overlap the image. And this one, I'm going to pull up here. So what do we see here? We will be able to see a standing wave form. Right, just like the image that you've seen. Right. So the image will be something like this. I will see a perfectly standing wave, something like this. But the drawing is not that good, so it will be something like this. So in the end, you will end up with a standing wave profile, something like this. Something like this. This is your standing wave, right? A perfect standing wave. So this is the image that you will see in one period. So that's why we call it standing wave. So the profile itself looks like it's not moving anywhere. Right? So it's not moving anywhere, then that's why we call it it's not standing wave, right? Because the profile is at like standstill. Okay, that is how the formation of standing wave. Now, if you notice properly, certain particle at certain point, for example, if I want to list out the particle at this point, so that means that at this point, even the four interference occur, four superposition occur at this point, this particle never move anywhere, it's remain at this place. So this is the point, we call it as node point. Right, so node point, this is also a node point. This is also a node point. So this is all node point. The particle at this point, even though it experiences four interference in one short period, but it always at the same point. So this is what we call a node point. And a particle that need to move a lot. That means that they need to move furthest away from equilibrium. So this particle we call it as antinode point. So the particle here we call it as antinode. So we use the symbol of A lah. Alright, so A is what we call it antinode point. So this particle they have to move the most displacement out of other particle. So this particle out here we call it an antinode point. Alright, this is how the characteristics of standing wave. That means that standing wave particle itself is not fair. Some particle have to move away a lot. Some particle don't need to move. They remain as stationary at the point. This is what we call for standing wave. This is the formation of standing wave diagram. Alright, so antinode point and node point. Now, so what happens if I want to know? So that means that we agree that certain particle like this point, it will oscillate between 2 points. For example, particle here, it will oscillate between these 2 points. This is your equilibrium in the middle. Certain particle here, antinode point, it will oscillate the furthest. So the amplitude here would be highest lah. This is your amplitude here. This amplitude is smaller. And then particle here, for example, I'm going to use different color. Particle here, it will oscillate between these 2 points. So you see here, the point each particle will oscillate is varies. That means that this one will have its amplitude, this one will have its different amplitude, this one will also have its different amplitude. Now, how do we calculate the amplitude of each particle here? Right, we can do that by referring to the equation. So this is the equation of standing wave. Right, what is 2a? A is the amplitude of the particular wave. After combine, you will end up with 2a lah. But how, the question is, how do we know the amplitude of each particle? Right, because we agree that the particle will have different amplitude. Right, so how do we calculate? We can use the equation that highlight here. This is 2a cos kx, position dependent amplitude. So if you want to calculate what is the amplitude at this point, certain point on the standing wave, so we can use this equation. This is the equation, right, to calculate the amplitude. So some books will call it as amplitude formula, right? The yellow one, highlight one, right? As an overall, this is our equation for standing wave. Now the last part is we need to know what is the differences between progressive wave and standing wave. So this is the three differences. The first one is the profile itself, the shape of the wave. So for progressive wave, the shape of the wave will move. You will see that the shape of the wave will move to one direction. So it means that the profile is moving through the medium. Now for standing wave, the shape that we see, it seems like it's not moving, static there. So the profile does not move. That is the first difference between progressive wave and standing wave. The second one is the amplitude itself. So this one for wave, I think this one we have learned previous subtopic. Wave, all particles will vibrate, will oscillate at the same amplitude. The only difference is some particle, on a medium will move first. But in the end, all particles will move with the same amplitude. Now, for standing wave, it's different. Some particle doesn't move, like we discussed previously. Some particle doesn't move, so we call it node point. Some particle will move,